So we're starting on measurement, but before we get into measurement, we're going to start by looking into a bit of Pythagoras, a bit of Pythag, which you would have done, I would say, back in year 8 and a bit in year 9. And our learning intention for today, so you don't have to write this, but I've got it here for you, is that we need to be able to apply the Pythag rule to find any unknown sides. The keyword here is your right angle triangle. So you're working with mainly triangles that have a right angle like that. Okay, it could look like that, it could look like this, it could look like this, but it's a right angle. Do we know why it's a right angle? What makes a triangle a right angle? Anyone know?
The 90 degree.
The 90 degree, and that's signified by these things. Right? These things, these little square things mean that the triangle is a 90 degree triangle. Okay? And does anyone know what the degrees of a triangle add up to? 180. Good. Always adds up to 180. Okay, so that's what we're going to learn. How to apply a Pythag theorem to unknown sides of a right angle triangle. And I'm hoping that by the end of today, in terms of our success criteria, that you'd be able to do these 4 things. If not, at least more than half of them, or half of it. Okay. So identifying what is a hypotenuse. Okay. Identify the theorem. What is the theorem of Pythag's theorem? Finding the length of the other short sides, and then using the theorem to actual real-world problems. Now, if you think about it, anyone know where in the real life might you use Pythagoras' theorem? Anyone know? A lot of builders and constructions actually use this. Okay, it's actually a rule that they use. If you ever get into building, it's a rule that they use to actually figure out lengths of unknown sides. So if, say, for example, they want to build a 50-meter tall, if they want to measure, the height of a building, but obviously they can't, they'd be able to triangulate it by using, for example, say this is the building, okay? And, or maybe, for example, they want to connect like a cable that runs like this to this point on the ground. Well, if you can see, that if they have the height of the building and the length of where the cable is to where the building is, they'll be able to find, for example, the length of the cable that they need. Okay, so there is practical applications for Pythag in the real life. So if you ever get into building and construction, it'll be useful. So let's get into it. So as a starter activity, Alice thinks of so let's go to the next page. Alice thinks of a number and squares it. So a mystery number. And then Peter thinks of a number and then he squares it. But what Jaden does is he realizes that his number squared is equal to the 2 numbers squared added together. What are the numbers that these people are thinking of, and how many different combinations can you create? So what this is saying is Alice thinks of, like, say, for example, 9 squared. Let's put that in here. You don't have to do this, but 9 squared. Anyone know what that means? What that equals? 81. Good. And then Peter thinks of another number. Let's go 2 squared. What's 2 squared? 4. Okay. And then Jaden realizes that the number that he's thought of is basically whatever these 2 squared equal, and then adding them together and then squaring that number. Now, it'll be tricky to actually think of that, but can anybody think of any numbers where this makes sense? So say, for example, 2 squared plus 3 squared, that would be 4 plus 9, which equals 13. Now, it's obviously hard to find a square root of 13, but I want you to come up with combinations of numbers where if you go, for example, 3 squared plus 4 squared, so if you do that, that's 9. 4 squared is 16. And then 5 squared equals, anyone know what 5 squared equals? 25. Okay, so what I want you to do is think of combinations of numbers where if you square them together, they equal the number squared as well. Okay, so that we're trying to learn here is figuring out that if you square a number plus squaring a number, it should equal the square of whatever number it is. Okay, and this is the basic principle when it comes to Pythagoras. So let's go to page 4. The theorem of Pythag it's a mathematical relationship between the sides Okay, sides of any right angle triangle. So it has to be the sides of a right angle triangle. And according to this, okay, we don't necessarily need to know fully what the theory might be, but it says here that the square length of the hypotenuse, which is the longest side of a triangle, is equal to the sum. So when you add A and B together, so when you add 9 and 16 together, for example, equals the length of the hypotenuse, or length of the longest side of the hypotenuse. Now, the main thing that I want you to learn here is that hypotenuse is this rule here. A squared plus B squared equals C squared. So please write that down in your notes there. I know it's already there, but to reiterate the point that Pythagoras in the rule refers to this rule here. So please write it down. A squared plus B squared equals C squared. Okay, so page 4 or slide 4. Now, does anybody know what is C? What's the hypotenuse? I just mentioned it before, but what's that in a right angle triangle? The longest side. Good. So for any right angle triangle, it's always the longest side. Okay, so if I look at this triangle, my longest side is this C. So every time you refer to the letter C, it's always going to be the longest side. Okay, and that goes for any right angle triangle. Dylan, are you writing notes? Yep, so that goes for any right angle triangle, longest side. A and B, okay, are any of the either shortest sides. It doesn't actually matter. You can actually call this B as well, and that A. There's no big difference between them, but just know that longest side is C, A and B is either of the other sides. Right, so when it comes to the rule can look slightly different depending on what textbook you're looking at. The way I've seen it is this, but I've also seen it like this. It means the same exact thing, yeah? So slide 5, A squared plus B squared equals C squared. It's the same exact thing, it's just flipped over. Okay, same sort of principle. However, there are also other variables that you need to find with the Pythagoras' theorem. Here are two variations of the actual rule, okay? Where if you're trying to look for A, so if you don't know what the A length is, then you'll use this formula. So A squared equals C squared minus B squared, or you can call it C squared minus B squared is A squared. It's the same thing, okay? And for this one, if you're looking for the B side, and you don't know what it is, well, you'll use this formula. Okay, it also looks like this. C squared take away A squared is B squared. Okay, that's variations of it. The main thing is, what I would like you to understand is there's different versions of the Pythag theorem, depending on what you're looking for. The way that I like to do it, and if you want to write this as well, is that if you're looking for the A formula, or if you're looking for the A side, you go A squared equals C squared take away B squared. That's if you're looking for A. Okay, it's basically the same as this. If you're looking for B, go B squared equals C squared take away A squared. And if you're looking for C, well, it's the normal. C squared equals A squared plus B squared. Okay, so the main thing you probably want to look at is these. So depending on which side is missing, if you're looking for A, use this. If you're looking for B, use this. If you're looking for C, use this. Now, I don't know why this hasn't been taught before, but there's also variations of this. And this is a shortcut on your calculator, where you can actually go, if you're looking for A, it just looks like this. Square root of C squared take away B squared. Okay, you can just literally type that in your calc. And these are the same thing, it's just a variation of it, yeah? If you're looking for B, square root of C squared take away A squared. And if you're looking for C, it's basically square root of A squared plus B squared. All right, so the formulas are actually the same. I just prefer to use this because it cuts out any other extra information that you don't really need. Okay, so it's a square root of that. All right, let's move on and let's actually put this to practice. Let's find the unknown sides of this. First, before we find the unknown side, let's label it. Okay, so let's label our triangle here. which one is my hypotenuse, guys? X. And which one is A and B? 7 and 4. Okay, let's go. 7 is A, okay, and 4 is B. Now for this triangle here, which one is missing? Which side is missing? C. So that means out of the formulas that we have, we're going to use the C formula, which is this. So now that we've identified it, let's use the C formula, which is C equals square root of A squared plus B squared. And according to this, C is going to be square root of 7 squared plus 4 squared. And then if you put that in your calculator, literally just type square root of 7 squared plus 4 squared. And that will be 8.06. Let's do the two decimals. Okay, so that means the length of C is 8.06. Okay, let's try this one here. Okay, let's label the sides. Which side is C? Always start with C. 14. So that's C. And which one is A and B? Okay, we'll make 8A if you want, and this can be B. Okay, so which side is missing? B. So that means we use our B formula, which is this one here. Alright, so that means for B, it's going to be square root of C squared minus the A squared. Putting that in, so it's going to be 14 squared, take away the 8 squared, and therefore B is equal to, so I'll just change these numbers, so this is 14, and this is minus, yes, so watch out for it, it's minus, and that's 8, which equals 11.48, we can round it up to 11.49. Okay, centimeters squared. It's just centimeters. Notice how the hypotenuse is always the longest side. So that makes sense that B, which is this side, is shorter. Yeah, so, it should be shorter. All right. Pretty straightforward. I think Pythagoras is one of those things most kids will already know. Okay, so if you get that, that's good. All right, so one of the main things that in Year 10 we do want to teach you, so let's go to slide 7, is 3D Pythagoras. So using 3D, okay, as a way to teach you guys Pythag is a little bit trickier, but it's more or less the same principles, okay? It's just in a 3D world. Now, if you look at this here, there's a pencil in here, and we want to figure out what is the length of it. Okay, how could we determine the length of the pencil? Anyone know? How can you figure out the length of this pencil? Obviously, you could get a ruler and measure it, but we're going to make it complicated and use Pythag. How can we measure the length of this pencil using Pythagoras? Anyone know? Yes, Michelle. So you want to figure out this length here?
Yeah.
Good. Okay, and why do you call it the hypotenuse, Michelle? Yeah, so here is, I'm assuming you're referring to this triangle. So she's referring to this triangle down here. It's the hypotenuse of this. Good, so we got to figure out, what is this guy? Oops. What's this length here? Let's just call it X. What else can we do? Yep, so that's one side. Is there any other sides that we can use? Good, top of the pencil all the way down to the bottom. So we need to also figure out what is this side here. So if you think about it, if I use my magical drawing skills and drew the triangle for the pencil, it would look like this. Okay, and then it would go down here. And the hypotenuse that Michelle is referring to is this. So if I knew this and I knew this, let's call this Y, then I'll be able to find this length here. Okay, so that's how we would do Pythag for a 3D problem like this. Let's say, for example, we've been given lengths. Yeah? So here is an example of that. I'm going to actually draw that for you guys because that's complicated. So here I can see this person has gone and used 7 for this length. So this is 7. Okay. And this length over here is 5. Okay, so if I were you, maybe draw this in. So if that's 7 and that's 5. What else do we need to have here? According to this, Yep, so that's that, 7, 5. Oh, and the height is 3. So this is 3. Okay, so there's two things we need to find here. Two triangles that we need to obviously find the length of. First of all, I have to find the length of this. Okay, so I'm going to draw that here and make it nice and neat for you guys. So I've got to find the length, and I would encourage you to draw this as well, but if not, that's okay. Just make sure you have it. So I need to find the length of this. And I'm drawing this triangle on the bottom here, down here. Oh, whoop, I drew it wrong, sorry. Sorry. Let me put it over here so it lines up properly. So we've got that, and it is, I'm trying to draw this. Okay, I'll just draw it like this, sorry. So this has to be 5, and this is 7. Okay, and I'm trying to find out what is this. So you can see how this length, the triangle here, or this part, oh sorry, that's not the hypotenuse, my bad. I suck at drawing, I just realized. Okay, it should be like this. There you go, that's better. Okay. So this length, you can see the hypotenuse of this length. So this length corresponds to the bottom of this triangle here. So I've got to find this unknown x. So let's do that. I already know, by the way, that this is actually 3. So let me fix that up. That's 3. So let's figure that out. Let's label the sides. Okay, what's my hypotenuse here, guys? The x, right? That's the hypotenuse. And what's a and b? Doesn't matter. Okay, let's go a, b. Right, so for that, I can see that I'm looking for this side length here, c. So the rule for c is square root of a squared plus b squared, which means that c is equal to 5 squared plus 7 squared. And that equals, if I put that in my calculator, 5 squared plus, let's go plus 7 squared, and that will equal 8.6. So the length of C is 8.6. Therefore, X over here is 8.6. Okay, and now from there, I can now figure out the length of the pencil because I've got two lengths here. So to figure that out, again, let's label the sides. Let's go. So this is C, this can be A, this can be B. And according to this, I'm looking for the length C. So again, use the C formula. Square root of A squared plus B squared. C is equal to 3 squared plus 8.6 squared. So what does that equal on my calculator? 3 squared plus 8.6 squared. So 3 squared plus 8.6 squared. That equals 9.12. Therefore, the length of C, which is this, is 9.12, I'm assuming in centimeters. Right, so with your 3D Pythag, a lot of the times, the main thing you need to look out for is that you're going to actually be looking for side lengths of more than one triangle in there. All right, that's the main thing you need to watch out when we do these 3D problems. Okay, so you're going to look at the side length of more than one triangle. Okay, that's what's going to happen for these. Okay, let's see, what else was there? All right, let's go to, all right, so I want you to go to the next one, the next page, which is page 9. And I'd like you guys to try and figure out the side length of HB, or prove the length of HB is 10.3. Okay, so let's go to slide number 9. Prove that the length of HB, okay, is 10.3. So working that out. See if you can work that out.
It already has the working out.
Is it? Yeah, well, I want you to do it. So what would you do? What would you do? Actually, if it already has the working out. Okay. All right, well, then maybe let's just discuss how would we find the length of HB here without looking at the working out. What two triangles do we need to look at here? Anyone see them? What's the triangle on the bottom going to be? looks like this. Okay, so you've got a side length of 9 here, and you know that this length should be the same as this length, so that's 3. So that's the first triangle, right? Okay, so once we find this unknown triangle, which is this, or this unknown length, okay, we're able to find the length of HB. So doing that, I know that that's C, so we're looking for the C formula. Square root of A squared plus B squared. And again, if you don't like skipping steps, remember that this is C, that's A, and that can be B. Okay, you don't have to do this. Okay, but good to know if you don't already, if you can already do it without it, that's good. So put that in, 9 squared plus 3 squared. Put it in your calculator. You'll notice as well, the way that I do this, I don't actually start a new, I'm not starting a new formula, I'm just going back to the same one, because it does save a bit of time if you just use what's already there. So that equals 9.49. Okay, so that means this length here is 9.49. Okay, I'm going to ask somebody, now what's the length, what's the other triangle going to look like? What are the dimensions? So if this is 9.49, so here, I'm looking at this triangle. Dylan, what would the dimensions be of this triangle? So that's 9.49. What would this be? 4. Good. So my triangle now looks like this. Okay, dotted lines here. This is 4 and this is 9.49. And in case you can't make sense of it, this triangle follows this. So that's the D corner. This is the B corner. And this is the H corner. Okay, so I'm trying to find out what is the length of HB. Alright, so for this, that's C, there's A, there's B, so I'm looking for the C formula. It's going to be A squared plus B squared. C is equal to 4 squared, 4 squared plus 9.49 squared. So putting that in my calculator, 4 squared plus 9.49 squared equals 10.3. I think it said here 10.3. Yeah, cool. So 10.3. All right, pretty straightforward. So the main thing to look out for here is with a Pythagoras triangle where it's 3D, you're going to be looking for 2 side lengths, okay, of the triangle. And mainly, if you look at the learning intention there, it's always going to be with a right-angled triangle, yeah? Cool. A couple more examples, and then you guys can start working, okay? So let's look at cylinders. What about your cylinders? So let's go to page 11, or slide number 11. How will that work for a cylinder? Okay, so here you've got a cylinder with these lengths, and I want to figure out what is length x, which is this. Figure out that diagonal length. Cylinders are pretty straightforward, although you might need to just figure out what is, understand what does radius mean, what does diameter mean, what does circumference mean, okay? Radius for any cylinder or a circle is the half length. Just keep that in mind. Okay, half length of circle. A diameter is the full length of the circle. Keep that in mind, please, when you do the circular cylinder questions. Okay, we'll get into a little bit more of this later on, okay, with the circles. All right, so I can see here that my cylinder, okay, forms some sort of triangular shape here. See? Okay, so if I was to translate that here, it would look like this. So this is what my cylinder looks like. I've got the length of 15. I've got a diameter of 8. So diameter, remember, is the full length of the circle. Anyone know what the radius of this circle might be?
4.
Good. So because radius is half, so it'll be half of that. But we're looking at the diameter here. Okay. So that means that that's 8. And in my triangle here, it's a right angle triangle. This is C. There's A, there's B. So that means I'm using my C formula for this. So C equals fifth A squared plus B squared square root of 15 squared plus 8 squared. And that would equal, calculator, again, just press back. If you're not sure how to do this, just press this button on your calculator. I'll press the back button so you don't have to start a new one. This is 15 squared plus 8 squared. Oh, sorry, yep. 8 squared. So that equals 17. Okay. Maybe we'll do one quick example of that, and I want you to figure it out. Maybe if there's space there, let's try this. So let's say I'm going to draw a diagram that looks like this. Okay. Looks like this. And Mr. Toto has put a pencil in there. So here's my pencil. I want to figure out the length of the pencil. If the height of this was, say, 20, and the radius, okay, so I'm going to go with the half length only of this, was, say, 7, okay, what is the length of the pencil? All right, I want you guys to figure that out. Okay, so figure out the length of this pencil. All right, see if you guys can do that. So what's the length of that pencil? Try and figure it out. So that's basically how we calculate. Mainly, the main thing to look out for in a cylinder one is that this length here in the bottom might be the diameter or it might be the radius. Just make sure you use the diameter though. All right. Okay, we can skip that one, I think. Yeah, we can skip that. All right, cool. So, in terms of just a bit of a vocab check, square length, okay, basically that means the square length of any sides of the right angle triangle, okay. The properties of the right angle triangle, okay, what are the properties of a right angle triangle? It's got obviously a right angle, it's got a starting with H, hypotenuse, and it's got two shorter sides, yeah? And why is it possible? Why is the theorem possible only with right angle triangles? Because it has to be the square lengths. Okay, so don't really need to know these too much. But that's basically it for this lesson, this part of the lesson, guys. So we're going to get into our exercises from our old and new textbook. So if you're doing 6B, so if you've got the old textbook, use this. If you're using the new textbook, we'll use this. Okay, so